got a really cool looking problem here. We have a bunch of nested radicals. We have a cube root, and then within there we have a couple square roots, cube roots within the square roots. We've got a lot going on. Fourth root even tacked in there. So when I'm looking at this problem, I'm just starting from inside of that radical. So I'm going to try to work within this cube root, and then within that cube root we have this square root right here. We have another square root right here, and then within each square root we have this square root, fourth root. So I'm just going to start knocking things off and try to clean everything up as much as possible, and then hopefully something nice will happen. So to start off, I'm going to write out my cube root here. So I have cube root. And then within there, I'm going to start right here. We have square root. Square root of 196 is 14. So the square root of 196 is 14 right there. Plus the fourth root of 16 is 2. And then we have plus, and then we have another square root. Try to make this look nice as possible. Cube root of 729, I believe, is 9. But let me just double check. Yeah, it's 9. So the cube root of 729 is 9. Plus the square root of 9 is 3. Plus the cube root of 27 is 3 also. So 3 times 3 is 9, times 3 is 27. And then we have plus 1. It's coming together. It looks a lot more manageable, even with just taking care of a couple square roots and cube roots and fourth roots, like just simplifying things down. It's already starting to look a lot cleaner. So now let's go to the next step of now adding those terms together. So on the inside, so this cube root, still have the square root here. 14 plus 2 is 16, plus, and then we get the square root. 9 plus 3 plus 3 plus 1. So that's going to be 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 1 is 16. So I probably didn't need to saturate that all the way over here. This is looking good because the square root of 16 is 4. Square root of 16 is 4. 4 plus 4 is 8. Whoops. So then I just have the cube root of 8, which is 2. So wow, we went from this crazy radical of the cube roots with a bunch of square roots, and all we did is we just started taking the radicals, like we're just simplifying the radicals down, and everything just worked out nicely where we got a perfect square here, so the square root of 16, we got another perfect square here, we got a perfect cube where the cube root of 8 is 2. So what looked pretty crazy and pretty scary of like not even sure where to start, just start doing something and simplifying some of those radicals. And it comes out to be a nice, clean cube root of 8 equals 2. So good problem here.